Imagine, if you will, a universe so vast that it defies comprehension. We're talking about an expanse so immense, so mind-bogglingly large, that our human minds struggle to grasp its true scale. This is the universe we live in. It's not just what we see when we look up at the night sky, but it's everything that is, has been, or ever will be. Now let's talk about the observable universe, the part of the universe where light or any information has had time to reach us. Scientists estimate that this observable universe contains about 2 trillion galaxies. Yes, you heard that right, 2 trillion galaxies. Each one of these galaxies is a vast city of stars, with each star possibly hosting its own system of planets, moons, and asteroids. But how do we comprehend such unimaginable distances? Enter the realm of astronomical units, light years, and parsecs. An astronomical unit, or AU, is the average distance from the Earth to the Sun. It's about 93 million miles. Now multiply that by nearly 63,000 and you get a light year, the distance light travels in 1 year. Now take that mind-blowing distance and multiply it by about 19.5 million and you get a parsec, one of the largest units of distance used in astronomy. But let's go back to the universe's colossal size. The universe is so vast that even light, moving at the fastest speed anything can travel, takes billions of years to cross it. And remember, that's just the observable universe. There may be more universe beyond what we can see. So in the grand scheme of things, our tiny blue planet is just a speck in the cosmic ocean. It's a humbling thought, isn't it? But also a fascinating one. Because despite its size, the universe is also a place of incredible beauty and complexity. A place worth exploring, a place we call home. So let's dive deeper into the cosmic ocean in the next scene. But the universe isn't just about size, it's a cosmic ballet of galaxies, stars, and planets. Imagine, if you will, a cosmic dance, where each celestial body plays its part, guided by the invisible hands of gravity. This isn't just a metaphor, it's exactly what's happening out there in the cosmos right now. Planets, like our Earth, are spinning or rotating on their axes. This rotation is what gives us our cycle of day and night. And while they're spinning, these planets are also moving or revolving around their parent stars, creating our familiar seasons and years. Stars, too, are in motion. They rotate around their own axes, but their movements don't stop there. They're also part of larger systems, like galaxies, and move in concert with them. Our own sun, for instance, is traveling at an incredible speed around the center of the Milky Way. Now, what about galaxies? They're also part of the dance. They move through space, interacting with each other through their gravitational pull. Sometimes they even collide and merge, creating larger, more complex galaxies. And what's choreographing all of this movement? The answer is gravity. This force, a fundamental aspect of our universe, governs the motion of every celestial body. It's what keeps planets in their orbits around stars, stars within their galaxies, and galaxies within their clusters. But the cosmic dance isn't just about movement, it's also about birth and death. Stars, for instance, have their own life cycles. They're born in stellar nurseries, regions of space dense with gas and dust. Over millions of years, these stars live out their lives, burning through their fuel. Eventually they die, often in spectacular explosions known as supernovae. These events scatter elements across the universe, seeding the next generation of stars and planets. Indeed, the universe is not just space, it is a symphony of cosmic events. Each celestial body, each galaxy, each star, and each planet is part of this grand performance playing out across the vast stage of the cosmos. Now, what if we told you that in this vast universe, we might not be alone? Imagine, if you will, a cosmic neighborhood beyond our own solar system, a place where celestial bodies, much like our Earth, orbit their own suns. These are what we call exoplanets, and they are key in our ongoing search for life beyond our home planet. The search for exoplanets is like a grand cosmic treasure hunt. Astronomers employ a variety of methods to trace these elusive celestial bodies. One of the most popular ones is the transit method. This involves observing a star for an extended period, watching for any dimming that might suggest an exoplanet passing in front of it. It's akin to watching a tiny bug fly across a distant, powerful spotlight. Another method, known as radial velocity, tracks the subtle wobble in a star's movement caused by the gravitational pull of an orbiting exoplanet. This wobble, though tiny, tells us a great deal about the planet, including its size and distance from the star. These methods have led us to some exciting discoveries. Just recently, astronomers have found a handful of exoplanets that exist in the Goldilocks zone, the habitable region around a star where conditions might be just right, not too hot, not too cold, for life as we know it to exist. Take, for instance, the exoplanet Proxima Centauri b, which orbits the closest star to our solar system. It's located in the Goldilocks zone and has a mass similar to Earth's, sparking curiosity and hope about the potential for life. These discoveries hint at the breathtaking reality that our universe is a vast, dynamic, and possibly life-filled cosmos. The search for other worlds, however, is far from over. It's a thrilling journey of exploration and discovery, driven by our innate curiosity and desire to understand our place in the cosmos. The universe is teeming with possibilities, and we are just starting to explore what's out there. We've barely scratched the surface of what the universe has to offer. As we peer into the cosmic abyss, our sights are set on new frontiers. Our ambitions are lofty. We dream of setting foot on Mars, the red jewel in our celestial backyard. With the advent of cutting-edge technology, this dream edges closer to reality. Missions like NASA's Mars 2020 and SpaceX's Starship aim to not only land humans on Mars, but also establish a self-sustaining colony. But our aspirations extend beyond our solar system. We're developing the technology for interstellar travel, with initiatives like the Breakthrough Starshot project aiming to venture to our nearest stellar neighbor, Alpha Centauri. These are no longer the dreams of science fiction. They are the goals of today's space agencies and pioneering companies. Our journey into the cosmos is just beginning. Who knows what wonders await us in the vastness of the universe?